Hello, I am Professor Semblat from ENSTA at IP Paris in the southern suburb of Paris, working in the field of seismic wave propagation and dynamic soil-structure interaction at various scales, from the scale of a single structure, what we call soil structure interaction, to the scale of an entire basin or an entire city, what we call site-city interaction. In fact, numerical methods, there are numerous, help to analyze seismic wave propagation. So it means we can predict the effect of seismic wave amplification at the free surface. So it helps to design for the seismic design of structures, and it is also useful to simulate dynamic soil structure interaction because it is a complex phenomenon. So it is a very important tool, but we need a lot of data, and we hope reliable data, so there's a strong need for such data from the lab, but also from the site, and it is really challenging to get some reliable data from the site to feed these numerical models, which are complex, but they totally rely on these data. Our online course on seismology and earthquake engineering covers a broad scope ranging from the structure of the entire Earth to, for instance, loss models for insurance companies. So it ranges from fault mechanics to wave propagation, radiation and propagation, soil dynamics, dynamic soil structural interaction, structural design. So it is really a very broad scope. So it is dedicated, in fact, to undergraduate or graduate students or practitioners, because people more involved on the engineering side may discover the seismologic side, and conversely, people more involved on engineering seismology may discover the structural dynamics, structural design. So it covers the broad range. It has been recorded with many different colleagues, even colleagues not only working on earthquakes, but also working on Marsquakes, that is, tremors on the red planet, on planet Mars. So it may be interesting for various types of publics. Since 2019, there's seismological sensors at the surface of the red planet, and it records the microtremors in the Mars soil, and it helps us to analyze the seismic waves propagating at the free surface of the red planet in order to identify the structure of planet Mars, and it helps to, in fact, adjust what we know about the structure and the history of the red planet. So it is really helpful to analyze such remote sensing recordings from planet Mars, but analyzed by seismologists on Earth.